Hey guys, Miss Udo here. We are going to try something just a little bit different this week for science. And so we are going to actually use our textbook this week. And I am going to kind of guide you guys through the text. And Dr. Johnson is going to facilitate the conversation. And so to prepare for our lesson today, you are going to need a couple of resources that are in your Google Classroom. And so as I guide the lesson here, you are going to want to follow along with the PDF copy of the lesson. It looks like your science workbook. And here is what that looks like. That is in your Google Classroom. And then the other thing that you are going to need is your graphic organizer. And the graphic organizer looks like this. And it is also shared in Google Classroom. And so with this graphic organizer, as we talk about non-renewable energy sources today, you are going to talk about where they come from. You're going to give a little bit of information on them. You are going to find a picture somewhere online of that energy source, and you're going to copy and paste it here. And then you're going to tell us how people use it. And so my suggestion is that as we go through the presentation, when we talk about these different things, that you fill in the information so that you know exactly what goes in each box, because this graphic organizer will be taken for a grade. And so again, for this lesson, you need your graphic organizer. You are going to want to follow along with the workbook pages that are posted in your Google Classroom. And I am going to be working from these slides right here. And so at this time, I'm going to ask that Dr. Johnson would pause the video so that you guys can take a second to locate all of your resources. All right, I'm going to assume that everyone has their resources, is paying attention, looking at the screen share, and ready to go. So here is our cover. And on our cover, you will see a picture. It looks like they're in the middle of a giant body of water. And there are several towers coming off of whatever this structure happens to be. And then it looks like there may be some crates here. And I'm sure you're probably wondering exactly what this is. And so our heading for today says, what non-renewable resources are used for energy? And the caption of this picture says, oil is buried deep within Earth's surface. In order to remove it, big drills have to dig down into the ground or even into the ocean floor. Many cars use oil and gasoline as fuel. Study the image to learn more. And so after hearing that caption, I would like for you to pause the video and discuss what you think might be happening in this picture. All right, let's move on. So now we are looking at pictures of cars, and I'm going to start back here with this picture. And so I'm going to show you guys 4 different pictures of cars, and these are cars as they have progressed over time. And so the caption for this car says, the look of cars has changed a lot over time. The way cars run is also starting to change. Many of the first cars were steam cars and powered by coal. And so when you think about coal, you probably think about charcoal, like someone may put on the grill, or maybe you have a family member who may have some type of coal-powered stove. And so coal is an energy source. And a lot of you probably think about the black briquettes when you think of coal. Some of you guys, when you were younger, you may have been told around the holidays that if you didn't act right, Santa was going to bring you coal for Christmas. Well, a long time ago, before I, was probably born, cars were actually powered by coal. And so take a look at this car, and I want you to just begin to think about how the way this car looks may be different from the cars that we are used to. So here's our next vehicle. This one looks completely different. And you've probably seen some cars that look like this on the road. It says some cars today are designed to run on electricity. Why do you think that we are seeing more and more hybrid and electric cars? And so at this time, I want you guys to pause and have a discussion about why you may be seeing more hybrid and electric cars. And so just to give you some context, normally we're used to seeing cars and when they pull up to something, it's a gas pump. But right here, you'll notice that this is not a gas pump. This is actually a plug, and this car is being plugged in to this energy source, and the electricity is what it's being used to run, what's being used to run it. And so the question is, why do you think that we are seeing more hybrid and electric cars? Now, this next car looks very similar to the cars that we're used to seeing the most on the road. And the caption says that most cars now still run on gasoline. Some run on diesel fuel, which is another fuel made from petroleum oil. And then our final picture looks completely funky. I don't think I've ever seen a car like this in my life, but I'm sure it's probably something of the future. And that's exactly what the caption says. Cars in the future may not use gasoline at all. They may depend on electricity or even on the sun as fuel. What other resources might be used to run our cars in the future? And so when I look at this car, what I actually think about is, and I don't know if you guys have ever noticed them, but sometimes when you ride through neighborhoods, on the top of houses, you'll see these big black things. And those big black things are solar panels. And houses that have solar panels use the sun's energy in order to run some of the things that would normally be electric in their houses. And this car actually looks like a solar panel. And so what I want you to pause and think about right now is what other resources might be used to run cars in the future. All right, guys. Well, before we jump into our lesson for today, one more thing I want you to discuss. And the question is, the cars in the photos above differ. They all look completely different from each other. What factors do you think car designers consider when designing a car that doesn't run on gasoline? What might be a problem of designing such a car? And so the question that I want you guys to discuss out loud right now is, what types of things do you think that car designers think about when they're trying to design a car that does not run on gasoline? Are they considering the size? Are they considering the shape? And why might they consider those things? And then what do you think are problems that they might run into when designing those cars? So pause and discuss now. All right, so I'm sure you guys have had wonderful discussions. So now we're ready to get into our lesson for the day. And so here is our objective. By the end of this lesson, you will be able to describe non-renewable resources and explain the effects of using them. And so now I want to remind you that you are going to need your graphic organizer, and you may want to follow along on the PDF. All right, guys, here we go. So let's look at materials that we use. It says resources around you. A resource is anything that helps you live. Your house is a resource because it gives you shelter. The clothes you wear are resources because they help to keep you warm. A natural resource is a material from nature that people can use. Water, air, trees, wind, fossil fuels, minerals, and sunlight are all examples of natural resources. All right, guys. And so I want you to take a look at this picture here. This picture just looks like an ordinary classroom, which I'm sure we are all completely missing being inside of the classroom. There are several spots or dots on this picture. And so I'm going to point them out now. And so there's one here pointing to the water bottle. We've got one right here. We have one here that I think is pointing to the stack of paper. Here's one pointing to the pencil. This one is pointing to the desk. And this one is pointing to the trash can. And so what I want you to do right now is I want you to pause the video and discuss the natural resources that may be in play in our classroom. And so each of these items are items that we've all seen before. What natural resources do you think are used in order to develop each of these items? Again, we're looking at the water bottle. We're looking at the curtains on the wall. We're looking at the stack of paper, the pencil, the desk, and the trash can. And so, what natural resources do you think are involved in the development of each of these items? Pause and have a discussion now. All right, guys, well, let's find out if you're correct. So let's start with the water bottle. The water bottle says the water you drink comes from a river, a lake, or an underground well. All right, and so the natural resource that we're talking about here, of course, is water. I'm curious to whether some of you may have noted that the water bottle was in a plastic container. And we're going to talk a little bit more about plastic a little later. All right, so let's look at the curtains. The curtains are made of cotton, and cotton comes from a plant. Here we have a stack of paper, and paper comes from the wood of trees. Did you guys know that? That paper is actually mashed up wood. Quite interesting. All right, here we have the part of a pencil, and you might have said wood here as opposed to saying wood with the paper. Well, here they're actually talking about the part of the pencil that you write with. And the part of the pencil that you write with is made of graphite. And graphite is a mineral that is also a natural resource. All right, let's look at our desk. The desk is made of metal, and metal is found in Earth's rocky layers. And finally, here it is, plastic. So our trash can is made of plastic, and plastic is made of petroleum. And petroleum is also known as crude oil, which is a fossil fuel. Great job, guys. Let's keep it moving. Limited supply. A non-renewable resource, as you learned last week, is a resource that once it's used cannot be replaced in a reasonable amount of time. Fossil fuels such as crude oil, coal, and natural gas are non-renewable resources. They are non-renewable because they take hundreds of millions of years to form. And so I'm going to suggest that everybody put their eyeballs on their graphic organizer at this time. So here we go. Use it, you lose it. Our first picture is of crude oil. Crude oil is the remains of once living organisms that were buried under the mud. And so here's our picture of crude oil. This is used for heat to fuel vehicles and an ingredient of many products like plastics and paints. And so I'm going to suggest that you pause and take a look at your graphic organizer and see if there is anything that you can add to your graphic organizer about crude oil. All right. So next we're going to highlight the coal. And so we talked about this coal earlier. And so here is our coal. And it says that coal is the the remains of plants that died millions of years ago. In some places, coal is used for heat and cooking. Some early trains and ships ran on coal. And so this is what that raw coal looks like. Again, I am going to suggest that you pause here and see if there is anything that you want to add to your graphic organizer about coal. All right, next we're going to be spotlighting natural gas. And this actually looks like my stove. And so it says natural gas is the remains of once living organisms. It is used for heat and as a fuel source for buses and other vehicles. Make sure you add to your graphic organizer. And finally, uranium. All right, so it says uranium, and here's our picture. Uranium is a natural element not from organisms, but found in rocks formed billions of years ago. Uranium is used to produce nuclear energy. It is a non-renewable resource, but is not a fossil fuel. All right, take a second to add that to your graphic organizer. All right, guys, let's see who was paying attention. Here is our question. How do these non-renewable resources help people in their daily lives? Select all that apply. And so that means that there may be one or more correct answers here. A says crude oil is an ingredient in many plastics. B says coal is used for heat and cooking. C says natural gas is used to develop nuclear energy. And D says uranium is used to make many plastic products. So pause and discuss which of those items is correct. Remember, we're selecting all that apply. And so it may be one answer and it may be more than one answer. So have a discussion right now and I will give you the answer in just a second. All right, guys. So the correct answer to this problem is A, crude oil is an ingredient in many plastics, and B, coal is used for heat and in cooking. All right. Here's our next check. It says, how are crude oil, coal, and natural gas different from uranium? Choose the best answer. How are crude oil, coal, and natural gas different from uranium? Choose the best answer. And so I hope that everyone is paying attention as we go through these questions because all of these questions will be found in our checkpoint at the end of the lesson. And so A says crude oil, coal, and natural gas do not come from fossil fuel, but uranium does. B says crude oil, coal, and natural gas come from fossil fuels, but uranium does not. C says there are no differences between crude oil, coal, natural gas, and uranium. And D says natural gas and coal come from fossil fuels, but crude oil and uranium do not. Please pause the video at this time and discuss the correct answer. All right, guys. Did you say that the answer was B? If you did, you're absolutely correct. Crude oil, coal, and natural gas come from fossil fuels, but uranium does not. All right. Let's go ahead and continue. It says collecting and processing. Each picture shows an example of how non-renewable energy sources are collected or processed. Fossil fuels such as crude oil, coal, and natural gas are first removed from Earth's crust. Then they can be used by electricity generating plants to provide electricity to homes and to businesses. It took millions of years for fossil fuels to form. Once these non-renewable energy sources are used up, it will take millions of years for a new supply to form. Non-renewable resources cannot replenish themselves. To make sure that people have enough energy for current and future needs, efforts have been made to conserve fossil fuels and use them wisely. The effects of carbon dioxide emissions are another reason why these efforts have been made. All right, guys, so let's take a look at this picture together. And so in this picture, there are several different types of energy sources, and we're going to just click on each one so that we can learn more. And so I'm going to start by clicking on A. So take a look at picture A, and I'm going to click on it now. It says coal, which is mined from deposits in the layers of rock, is taken to electricity generating plants to be burned and converted to electrical energy. Some early trains and ships ran on coal, and that's something we learned about a little earlier. Let's look at B. Has anybody ever seen something that looks like B? It says uranium is mined from rocks and is used to make large amounts of energy, which is then provided to homes and businesses for heat and electricity. It is a fuel source for nuclear energy plants. Let's take a look at C. That looks almost like what we saw in that first picture when we started our lesson. It says gasoline used as fuel in vehicles comes from crude oil, which is drilled from underground wells, including wells that are underwater. Crude oil is used to make paints and plastics. It is also burnt to generate electricity. And our final picture is D, and it says natural gas is extracted from rock formations deep underground and then transported by pipeline and burned for the use of electricity generation. Let's keep going. All right, it says here that we are going to watch a video to discover more about the electricity that runs your home. It says the electricity that you use in your home is generated in an electricity generating plant or station from some type of energy resource, most likely coal. All right, let's watch our video so that we can learn more.
Electricity in your house allows you to turn on lights, cook your food, and charge your devices. But where does the electricity come from? How does it get to your home? Electricity is made in electricity generating plants, or stations. Electricity generating plants, or stations, use non-renewable resources, such as coal and natural gas, to make electricity with large machines called generators. The electric current is then sent through something called a transformer, which allows the electricity to travel long distances. The electric current travels through networks of wires, or electrical lines, that stretch across the country. It then goes through what is called a substation, which changes the electric current again so it can travel through smaller electrical lines. As the electric current travels from the substation to your home, it is changed one more time so that it can safely enter your home. The electric current travels through wire inside your home to all the outlets and switches that you use every day.
All right, interesting. Let's keep it going. It says, place the steps in order to describe what happens before your bedroom light comes on when you flip the switch. And so I'm going to see if I can get all 8 of them on the screen here. And so what you are doing is you are placing the steps in order to describe what happens before your bedroom light comes on when you flip the switch. And so here are the 8 steps that they give you. It says a generator produces electric currents. Turbines turn a generator. Electrical lines carry electric currents. Steam runs turbines. You flip a switch. Hot water produces steam. Your bedroom light comes on. And coal burns to produce heat. And so please pause the video now and see if you can put these in order to share what happens in order for you to be able to turn your bedroom light on at your house. All right, let's see how we did. And so here's the order you should have come up with. Coal burns to produce heat, which of course we talked about coal being our natural resource, and so that would be our starting point. Hot water produces steam. Steam runs the turbines. The turbines turn a generator. A generator produces an electric current. Electrical lines carry electric current. You flip a switch and then your bedroom light comes on. Isn't it crazy that there's that much of a process every single time you flip a light switch in your house? All right, guys. So before we move on, let's do another quick checkpoint. This one we're not going to do a pause for. I'm just going to stop speaking for just a second, and you guys can unmute quickly and try to yell out the answers, remembering that you want to make sure you're paying attention because these same questions are going to be found on your lesson quiz. And so let's read together. It says all living things need. Our choices are fossil fuels, resources, or generators in order to live. What do all living things need in order to live? What do you think the answer is? All living things need resources in order to live. Some of these exist naturally all around us and are called natural resources. Some natural resources are considered, we've got fossil fuels, renewable or non-renewable, because they cannot be replaced. If they cannot be replaced, then what are they called, guys? That's right. Non-renewable resources cannot be replaced in a reasonable amount of time. Examples of non-renewable resources include blank, such as coal, crude oil, and natural gas. And so we didn't include uranium here. And so we know that these are called what, guys? That's right, fossil fuels. Great job. All right, let's move on into the next part of our lesson. All right, guys, so this next part is going to be a little more interactive. I'm going to read a little bit, then I'm going to post some questions on the screen for you guys to pause and discuss. So let's keep it going. Search and find. Exploration number 2. Digging a little deeper. Non-renewable resources are being used at a much faster rate than they can be replenished or replaced. Today, there is more demand for coal and crude oil than there ever was before. Due to crude oil being used up, big drills called oil rigs dig deeper into the ground to find crude oil. People now need to dig deep or strip away the surface of the earth to reach the coal. And so here we have a picture. And it says that we're going to study the pictures and the captions to discover more about how people get their non-renewable resources. And so taking a look at our picture, we've got stage 1, and take a look there and see what that looks like. We've got a stage 2 that now has buried once living organisms, and then a stage 3 that has rock layers, crude oil, and then there's another layer of rock down here. It says crude oil formed from once living organisms that died millions of years ago. Pressure and heat from rock layers above the buried once living organism form the crude oil. Today, mechanical drills dig deep into the Earth's rock layers to remove the crude oil and natural gas. Natural gas is a byproduct of both crude oil and coal. It is formed along both of these fossil fuels. Now, let's take a look at this picture. We've got a completely different stage 1, stage 2, stage 3, and our environment actually looks a little different. Here it says that coal formed from plants that died millions of years ago. Over time, the plants were squeezed and heated by layers of rock pushing down from above. Today, surface and underground mines are used to remove the coal. And here's our last image. It says uranium is an element found in certain rocks and rock layers. It is removed by surface mining or by deep underground mining. It can also be removed from rocks by leaching, fusing water and chemicals to release it from rocks. Before the 20th century, people relied mainly on wood and some coal for heating and cooking. Burning coal started the industry age with the development of steam engines that fueled trains and other machines, as well as electricity generating plants. Cars and other engines increased the use of crude oil as a source of energy. As technology improved, people found ways to mine and use natural gas and nuclear energy. And so here's the question I want you guys to think about now. What do the methods of extracting these fuels all have in common? And so when we looked at the different layers and we've talked about gathering these natural resources, what I want you to pause and talk about now is what do the methods of getting fuel have in common? So I'm curious to hear what you guys came up with. But one of the things that I'm thinking is probably a popular answer is that in order to get any of these fossil fuels, you have to dig below the Earth's surface. I think that that was probably your most common answer. In order to extract or get these fossil fuels, you have to dig below the Earth's surface. None of these just sit on top of the ground. Just you walking down the street and you can just see them. All of the fuels that we need, you have to go deep beneath the Earth's surface in order to obtain. All right, guys. So now we're going to talk very briefly about where these non-renewable resources are found. It says scientists and engineers use special renewable resource technology to locate, remove, and process coal, crude oil, and natural gas and uranium. Each of these methods has certain benefits and risks. Some create pollution, and pollution is waste products that damage the ecosystem, which is something you should all be familiar with. And so let's take a look at this map. This is a map of the United States. And there are hot spots where each of these non-renewable resources is found. And when I say hot spots, that just means that there's more of that non-renewable resource located in this particular area than in most others. But if you take a look at our key, where you see the coal, and so that's this brown thing. And so these are areas where you can find coal, where you see this thing that looks like water droplet, but it's not. It's actually fire, like a flame gas. This is natural gas. And then these black things right here are coal, and our yellow sun belt, that is our uranium. And so before I begin clicking on each of these tabs, I want you to pause and just have some conversation around what you may notice about where these resources are located. Does it appear that there's more of certain types of resources in certain regions of the United States? Do we notice that there are regions that may not have a certain resource or any resource at all? And so pause for a second and have some conversation around what you notice when looking at this map. All right, guys, so let's check out our hotspots. Let's start with this first hot spot up here. And it says natural gas is found mostly in Alaska, Texas, Oklahoma, New Mexico, Wyoming, and Louisiana. All right. And then here we've got the uranium. It says the United States was once the leader in uranium mining. Today, however, uranium is mined in only a few places, including Utah and Wyoming. And so when you look at our uranium, you'll see that there's literally only 3 little pop-up spots for uranium. It is in short supply here in the United States. And of course, because it is a non-renewable resource, it would take hundreds of millions of years for us to get any more of it. All right, let's see what we have here next. Coal. In the United States, crude oil is found mostly in the Midwest, South, Southwest, Alaska, and around Pennsylvania. And so we can see that right here. So here's the Pennsylvania area right here. And we are looking at coal and the locations that the coal pop up. And then, looking at the oil and where it pops up. And then finally, our coal. It says the Midwest, Montana, Wyoming, and Pennsylvania are the main sources of coal in the United States. All right. All right, let's see who was paying attention. Natural gas, blank, and coal can be found in the Midwest. Natural gas and uranium can be found in New Mexico and blank. Oklahoma has both blank and crude oil. Pennsylvania is one of the main sources of blank in the United States. So let's take a look. Natural gas, blank, and coal can be found in the Midwest. Is it crude oil, uranium, or natural gas? Well, let's use our process of elimination. Which one do we know it's not? That's right. We know it's not natural gas because it already says natural gas right here. And so now we can eliminate choices and we're either looking at crude oil or uranium. So which of these, crude oil or uranium, can be found in the Midwest? Look at your PDF if you need to. Remember, we can always refer back to our picture. And so we are talking about natural gas. Natural gas is the one that looks like what I told you is not a water droplet. Talking about the Midwest, natural gas, crude oil, and uranium. Which of these can be found in the Midwest? Our crude oil is our drums, and our uranium is our yellow spot, which is found in the Midwest, which is mostly found in the Midwest. Did you figure it out? All right, we're going to go with crude oil. It says natural gas and uranium can be found in New Mexico. And where else can natural gas and uranium be found? Let's look at our map again. Here it is. Natural gas and uranium. And our choices are Alaska, Montana, Wyoming. Natural gas and uranium. Remember, uranium is the yellow one you don't see a lot of. Alaska was one of our choices. What were our other choices? Alaska, Montana, and Wyoming. So Montana, guys, is where on our map? There's Montana. And then we have Wyoming, which is located right here. And so which of those has natural gas and uranium? That's right, it's Wyoming. All right, the next one says Oklahoma has both blank and crude oil. So let's take a look at Oklahoma. Oklahoma on our map is where? Do you know where Oklahoma is? That's right. This area right here is Oklahoma. Okay, that's Oklahoma. And what do you see here? We see natural gas and oil. And so let's see, natural gas and crude oil. So our answer is what? That's right, natural gas. And then Pennsylvania is one of the main sources of blank in the United States. Take a look at Pennsylvania. Pennsylvania is up here. What did they tell us? It is one of the main sources of, did you say coal? That's right, coal is the correct answer. All right, let's keep it moving. All right, so here we go with another quick check. I am going to quickly read through these and then I want you to pause the video and discuss which of the non-renewable resources listed on the bottom match with the pictures on the top. So in the first picture, it says many kitchen stoves cook food with an open flame. A fossil fuel is piped into the stove where it ignites and heats up the food. Which non-renewable resources is at work here? The next one says early trains had steam engines. A fire heated up water, which turned to steam. The steam then helped the train to move. Which non-renewable resources at work here? And then paint is a product of a fossil fuel. The same product that is used in paint is also used in plastic, rubber, and soap. Which non-renewable resource is at work here? Please pause the video and discuss which item goes where. All right, are we ready to answer? Okay, well, on the stove, I told you guys I have a stove just like this in my house, and this is a gas stove. And so our non-renewable resource here is gas. In the very beginning of our lesson, we talked about what is used to power trains and some of our early vehicles. We talked about steam engines, and that is coal. And when we are talking about paints and things like that, we are talking about oil. Did you guys get all of those correct? I hope so. All right, great job, guys. All right, guys, we are almost at the end of our lesson. But before we finish up, let's talk a little bit about pros and cons, because with everything, there are things that are great and things that are not so great. It says the pros and cons of something are similar to the benefits and the risk. The pros are the positive things about it, and the cons are the negative things or the drawbacks. Using fossil fuels has some pros and some cons. A pro is that they give us affordable fuel. A con is that using them often causes pollution or harmful substances mixed into the water, the air, and the soil. And so we have some pictures that we are going to take a look at just very quickly. We're going to study the pictures and learn a little bit more about each fuel. And then there's going to be a chart that you guys are going to complete at the end. And so we've got another picture of a train here. It says humans have used coal for energy for thousands of years. Some forms of strip mining of coal can harm the ecosystem. We've got that same car from earlier, and it says many vehicles run on gasoline. It says hazardous oil spills have occurred when transporting crude oil. So when they're moving the oil from place to place to get it to where you need it to be, to get it to the gas station, to get it to all of these different locations, sometimes we have big oil spills, and that can be bad for the environment. It says airplanes use fossil fuels to run their engines, and this fuel is expensive and also adds to pollution of the air. This picture says burning fossil fuels in cars and at electricity generated plants generates energy, but it also creates pollution and harmful gases in the Earth's atmosphere. And so we're talking about that air pollution again. And then burning natural gas and using nuclear energy produces less pollution than other fossil fuels, but transporting uranium is dangerous. And so now let's talk cause and effect. We've got cause on one side, and so this is the things that we do, and effects are the things that happen as a result of the decisions that we make. And so what I want you guys to do as a class at this time is pause the video, and we have some tabs under the bottom, and I want you to discuss as a class which cause or which effect align in order to complete this table. And so pause the video, read what is on your screen at this time, and match each cause and effect. All right, are we ready to discuss? Well, the first one was a cause. And so our effect is pollution and harmful gases are added to the air. And so what would cause this? Correct answer, fossil fuels are burned, and then pollution and harmful gases are added to the air. All right, the second one, new nuclear plants are built. And so if new nuclear plants are built, then uranium is rare and must be moved long distances. Let's take a look at the next one. It is a cause. Well, the effect is habitats, and farmlands are lost. And so resources are surface mined, and then habitats and farmlands are lost. And then finally, crude oil is transported. Well, when crude oil is transported, oil spills pollute the water and destroy wildlife. Great job, guys. All right, so the very, very last thing that we're going to talk about today is hybrid cars, which we kind of touched on in the very beginning of our lesson. And so hybrid cars use two or more different methods to generate energy to run the car. There are different types of hybrid cars. Some are newer hybrid cars and can run on both gas and electricity combined. And the image below shows a standard hybrid. And so here's the hybrid car. and we're going to click on each of these pictures to learn more. And so we've got a little box looking thing here. Let's see what this box tells us. So it says this hybrid car uses gasoline as a partial fuel source. And so we've got the gasoline and it's coming into this little box here. And then we've got this green thing here. Let's see what we learn. It says this hybrid car also has a battery where the electrical energy is stored and the fuel engine charges the batteries. And so here we've got the space where the batteries are housed. So the gas comes in here, and then we've got our battery here, and then we're going to connect up to, what do you guys think up here? The engine. So in hybrids that use gasoline engines and electrical motors, there is a switch that turns one off when the other is in use. And so this particular car has a gasoline engine and an electrical motor. And then our last little piece over here just says the electrical generator. Many gasoline electric hybrids have brakes that are set up in an electrical generator. When they are applied, the electrical charge generated is stored in the battery. Interesting. All right. So our last point of discussion for today is I'm going to ask you guys to make an inference. And so that's like a hypothesis. You're going to make an educated guess based on the information that you've learned about a hybrid car. It says some cars run entirely on electric energy. How do you think their batteries might be recharged with electricity? And we're not going to enter our answer in the space below. We're just going to talk about it. So how do you think that batteries of cars are recharged with electricity? How do you think that works? Take a second to pause and answer that question at this time. All right, guys, thank you so much for paying attention today. With the remainder of your class time, you are responsible for completing the non-renewable energy portion of your graphic organizer. The non-renewable energy portion. The graphic organizer is 2 pages. 1, 2. Today, we only talked about non-renewable energy, and you are responsible for completing this with the rest of your class time. And so you are going to write how it's made or where we get it from. You're going to give a little bit of information about each one. You are going to find a picture, and then you are going to talk about how people use it. We have covered all of those things in a lesson today. If you need to refer back, you can look at, remember those PDFs that I sent to you that are in your Google Classroom, because all of your information is here because we talked about it. And so that is what you are responsible. Let me find it so I can put it back on the screen. There we go. That is what you are responsible for with the rest of your class time. That is a classwork grade because you guys will discuss that. And then you are also going to get a lesson assessment. Remember, I told you that we talked about all of those questions in class today. You guys went and you discussed them out loud. Those same questions are going to make up the lesson assessment, and that will be a Google form that will be that is posted under today as well. And so please go ahead, report back to that non-renewable energy graphic organizer as you see on the screen right now. You are to continue working on this because you should have filled in some of the information as we were having our class discussion. So go ahead and knock that out so that you do not have to do it later, and then do your lesson assessment. Thank you so much, and I will talk to you guys very soon.